Hello everyone, welcome to ashatech.com, your engineering sciences channel. In this video, we are looking at how we can solve a second order differential equation in Python. Now, we are given a second order differential equation that is non-homogeneous, d2x dt squared minus x is equal to cosine of t. This is a second derivative of x with respect to t, then subtract x is equal to cosine of t. And we are given that at t equals 0, this x is equal to 1. And at t equals 0, dx of dx dt, or the first derivative of x with respect to t, is equal to 1 also. Now, we are going to use sympy. So we have to import sympy as sp. Another one can say import sympy as sim. Then that's what you're going to use, because probably you don't want to write the whole sympy. Otherwise, you would write the whole sympy then as you define your functions. So now we are going to define t as a symbolic variable. So that's why we are saying t is equal to sp dot symbols of t. Then x, we have to define it as a function of t. So since we already have only one symbolic variable, so x is going to be sp dot function of x. It is x as a function, but is a function of t. Then we are going to also define this differential equation, and the function that we are going to use is sp dot eq, whereby eq is going to define our equation, the differential equation specifically. So how do we write this differential equation? After putting a capital EQ, we open brackets, then we have x dot diff tt. In other words, here we are meaning this is a function x, which is a function of t, but the first part is telling us this is a second derivative, so we have to say it is diff tt to show that it is a second derivative. Then minus x of t, we have to remember to put this bracket, then t, because we are telling this program that x is a function of t. Then we have to put, if we had anything, like for example, maybe we had here plus maybe 5, we could bring it here. So here we would also say plus maybe 5, then comma sp dot cos of t. So after a comma, that's where we put the equivalent of this differential equation, and we are saying the equivalent of this differential equation is cosine of t, which is at the end of the equal signs this side. So since it is not there, let us remove it. So we proceed with what we have, and after putting our cosine of t, we close the brackets. So let us print this differential equation, and we see whether it is in the format that we want it. So we are going to use the print diff eqn, because diff eqn is the differential equation that we are dealing with now. So we wait. So that is the differential equation. It is telling us that we have minus x of t plus the second derivative. This means the second derivative of x with respect to t. Then comma, it is equal to cosine of t. So it is telling us we are right. We are on the right track. So we can proceed, and maybe we can maintain our print of that equation. Then now we want to define the result of the solution. Using the dsolve function, we want to now have that differential equation solved given the initial conditions. Now we are going to use initial conditions ICS, and this is going to be a dictionary that has a key and a value. So our key in the first place is x, the value of that defines for us the value of t, and also the value of x. So the first one is x of 0. X of 0 is telling us the value of t is equal to 0. Then now we want to define what will be the value of x when it is equal to 0. We said according to what is given, it is equal to 1. Then we go to, also we are given that dx dt at t is equal to 0 is also equal to 1. So what we do, we also put a comma. Remember, sp.diff. If we don't put sp.diff, then it will be not recognized. So what we do, we come and say the first derivative, of course, it is going to be diff x of t with respect to t. Then we substitute when it is equal to 0, the value of this, now the key in this dictionary is going to be sp.diff x of t comma t, then dot substitute at t is equal to 0, the value now, the value is going to be 1. So now we want our function, this code, we want it to print first of all the differential equation and also print the solution. Maybe we call it solution. So this is result, and we can call it maybe the solution. Solve. So having defined everything, let us run. So our differential equation is the second derivative of x with respect to t minus x equals cosine of t. And the final answer is 5 times exponential of t divided by 4 minus cosine of t out of 2 plus the exponential value of negative t divided by 4. Maybe I can create a gap in between these two for me to show a spacing in between them. So I can say print, I put that, then I also say print bracket, I say that, then I say print bracket, I put that. So when I run, it should create a gap. So now I can see them clearly. My first equation is the equation which is the differential equation. The last equation is a solution to the differential equation. So this is how we can solve the differential equations given the symbolic, given the initial conditions. Then we are able to produce the general solution of the differential equation using the function dsolve, and also using ICS, which is the initial conditions that gives us a dictionary of key value. The key is the value of x, the value is actually the value of x, then the key is when t is equal to 0 or when t is at a particular value, then the value that we are getting out of that key is going to be 1. Then the same thing, we define the dy dx or the dx dt, which gives us the first derivative of x, and then it gives us the value at t equals to a particular value. So that is it. Thank you so much, and see us in the next lecture.